I promised to talk about jeforth, but things came up very fast. So instead of I've already talked about jeforth in the FIG meeting. So I thought I would just go ahead and report to you the newest object-oriented project, which is the ceforth 403. And I will put the link to the Java presentation on the chat. Okay, so if you are interested in the Java, you can go download the Java eforth. But this morning I will talk about the C++. Okay, ceforth. ceforth was eforth written in C, and the earlier version, ceforth 21, was written in CCP and run on Sigwin. And that implementation has the fourth dictionary compiled by eforth outside of the C compiler. And then in 2017, ceforth was upgraded to run on Visual Studio. And in this implementation, I had a meta compiler written in C, which will build the fourth dictionary in runtime. And that one was used in ESP32 eforth. Okay, now this ceforth 403, it was written as a C++ console application in Visual Studio 2019 community. And it runs in a console window like an old-fashioned Forth program in a DOS terminal. But you know, the ceforth 33 was vanilla C, and this ceforth 403 is a C++, a true C++ object-oriented implementation done mostly by Cho Chen Lee. And in this presentation, I just give you a few slides which shows the IDE Visual Studio project, and then I built the ceforth as a console project, and it can boot into kind of a DOS window. And I'll show you the words, numbers, error exceptions, and then the lesson 403, which is the basically a tutorial. And lastly, I'll show the calendar as an application. So here is the Visual Studio 2019 community, and that's the IDE. And in the main window, you see the code, the C++ code, and it's object-oriented, and it makes lots of use of the list structure in C++. And Chu Chen implement fourth list as an extension of the regular vector in C++. And he put in lots of features in the list so that we can implement stacks, dictionary, fourth word, fourth objects, and also object lists in fourth high-level colon words. And this one you have to compile it, and that's what it built. You built the project, And this screen shows the result of the build. And basically, this is the ceforth 403.cpp file. It was compiled and rebuilt all, and it was successful. So we got the C++ program compiled. And if you push the button which says the debug without, let me see, run without debug, okay, and you get the screen. And this screen signs up saying ceforth 4.03. So the ceforth is running, and ceforth is object-oriented. So all forth words are basically objects. And here, if you type words, and you get a list of all the forth words implement in the dictionary. And these are all primitive words. They're all written in C++, just like assembly, okay? And we have up to 0, which is dupe, up to boot, which has a token of 99. So this implementation, we have 100 words. It's a very simple, very vanilla type of forth, but it works just like a regular eforth, but it's implemented very small. It's a very small system. We only have 100 words, and the source code is about 400 lines. And then after it executes a word, it will report the stack. And the stack, and if you type a sequence of 1, 2, 3, 4, 5, and all the words are pushed onto the stack, and the stack picture is shown. And this is an implementation where we cache the top of stack in a top register. So you see here 1, 2, 3, 4, 5 are on the stack, and -1 was first initialized into the top of stack. So you always have this -1 on the stack. And if you don't have this -1 on the stack, you're in trouble. Okay, here is how to clear the stack. The easiest way to clear the stack is type in some gibberish, and then the forth interpreter couldn't understand what you mean, and shoots back a question mark, and then it clears the stack with only the top of stack initialized as a -1. Okay, here is the lessons file. In all my eforth system, I include a lessons file. And this lessons file has 17 lessons or more, just to show how you use this eforth system. And eforth system is slightly different from NCforth, because lots of NCforth words, required words are not implemented here. But it is a self-sufficient system that you can use it to do lots of things, as the example, the lessons would show. Okay, what you do with the lessons is you open it in a text file editor. You select all the text and then copy and paste into the this forth window. and it would compile all the words in all the lessons. Okay, and here you see the last part of the results of the compilation. The last word defined as a greet. Okay, and it compiles satisfactorily. You can scroll back this window, this console window, to see all the results generated by all the files, all the lessons. Okay, this, if I can just scroll back into one of the very interesting application, which is the calendar program. And at the end of this calendar program, it executes 2021 May, and it generates the calendar of May 2021. And this is not a trivial task, and it is a little bit involved, and it exercises lots of stack operation, math operation, input and output in words, and when I'm developing the ceforth, this is the last application which I got to run correctly. Okay, there's lots of things has to be fixed before this thing prints out correctly. Okay, this is the all the words that's being compiled in the system. If you type in words, the first word in the system is a dupe, and the last one in the last primitive is boot with a token 99, and the rest of the words up to greet, which is 225. So all the 17 lessons compiled about 150 words. And I show you the calendar of May 2021. Why not show the calendar of this month? So I type in 2021 August, and I got the calendar of August. And we are at the 14th of Saturday. So this thing worked, and I'm very happy with that. Okay, the fourth implementation in this ceforth, basically, it has an auto interpreter. A forth virtual machine has an auto interpreter to evaluate word list in text strings, or we call it a text interpreter. And we have also an inner interpreter to evaluate compiled word list. So all colon words, the primitives, we implement all 100 words in primitives, all 100 primitive words in C++ code. And all the words that you compile are colon words. And we need an inner interpreter to interpret all the colon words. And of course, we need a return stack to execute nested word list. And we need a data stack to pass parameters among the words. And we need a serial I/O device. And in here, it is the console window of C++. So the eforth virtual machine can be programmed very efficiently in object-oriented languages. And so far, I have done 3 systems. jeforth in JavaScript and jeforth as ooeforth. And now there's a ceforth in C++. And they are all, we all take advantage of the object-oriented features to build the lists and all the structures that we need. All fourth words are objects. So we have primitive words, we have outer interpreter and inner interpreters can all be written very elegantly in JavaScript, in Java, or in C++. So these three systems, they are very tight, very small. And I think most of them has 400 lines of more or less code. And so I say that ceforth, jeforth, and ooeforth, they are poetry. Very beautiful. And the goal of ceforth403 was really to replace the eforth running in ESP chip, which I did a number of years ago. After I did all this object-oriented forth, looking back into the ESP32 eforth, I felt embarrassed. It was terrible. Okay, and it has to be upgraded. So Chu Chen has already ported eforth403 to ESP8266. That kit he had in hand. He's buying a ESP32 kit, so he will move it to ESP32 shortly. We hope a simpler forth will encourage people to optimize ESP32 for more customized applications. So I like to tell you a story. This is the Chinese folklore. And two quarrelsome frogs live in a deep well. And they heatedly debated how big the sky was. With objective observations and accurate measurements, they finally agreed that the sky was circular and 5 feet in diameter. And I also have a nice picture to show you the two frogs arguing about the sky in the depths of a deep well. Okay, so I live in a deep well called Forth, and I look at the OOP, object-oriented programming. With my Forth friends, we came up with jeforth 614 in JavaScript and ooeforth 204 in Java and ceforth 403 in C++. We decided OOP was round and 5 feet in diameter. Thank you. I will stop screen.
Yeah.
And take questions.
Dr. Ting, can you give us a demonstration on how the fourth words are object-oriented? I don't quite understand that.
Wait a minute. Say it again.
Can you give us a demonstration on how fourth words are object-oriented? I don't quite understand that.
Okay. I think the best way for me to explain it is to show you the source code. Okay, let me just briefly scan through the source code for you. So can you see the screen? Okay, this
Yes.
is the ceforth. Okay, and the first part is a fourth list. This is the structure. So it's building all the structures, the stacks, the dictionary, and the primitive primitive fourth words and the codon words. Okay, and then we have this a magic class called code. This is the class which has constructors which build all the structures, all the fourth words. And there are different kind of primitive words, and all the user-defined words are codon words. And everything else beside all the primitives are codon words, including the constants, variables, array, and whatever you have. Okay, so we use this what I call the one size fits all class to build all the fourth objects. And all the fourth objects are collected in a dictionary. And so this return stack is a fourth list. Data stack is also a list. And dictionary is also a list. Okay. And we have some base, and we cache the top of data stack into this register top. And IP and the WP are the where am I pointers and tracking if you are in a nested list of colon objects, where you are, which object are you currently executing, and where you are in that particular object list. So here is the some word which you find, which allows you to search dictionary for a particular word, and many other things which you needed to construct different objects. And here is the inner interpreter. We have colon words, which is an object, and which has an object list. So this inner interpreter just go through that object list and execute every one of them in sequence. So this inner interpreter is getting very simple, very straightforward. And we have a dump, we have a C, very interesting decompiler, and the words which are written as routines in C++, but they are called by respective fourth primitive words. Okay, here is the dictionary. So code is used to construct all the primitives. And you can see the stack primitives because we cache the top of stack. All these stack operators becomes quite very simple, okay? And especially all the ALU operations and the logic comparators, they are implemented very simply in C++. And they are written similarly with Java and also with JavaScript. So all these primitives are written in the native programming language. And that was one thing which Sam Chen in Taiwan Fig showed us. So I just adopt his way of doing things and implement all the primitives in objects at the time it was JavaScript. And here is something interesting, because the branch, if else then structure are implemented in a branch object. Okay, inside the branch object, you can have two different alternative paths, and they are both implemented as colon lists. Okay, and here are the loops object, and this loops object implements begin, while, repeat, begin again, begin until, all these loop structures. And then here is the cycles, which implemented the for and the next loops. Okay, so all the control structures are reduced to single objects. And so in the colon definition, we don't have anything other than objects. And in the colon definition, all the object lists are pure, simple, linear list of fourth objects. And then we have the compiler of the variable, create, and constants. And we also implement arrays, okay? And you can allocate space for different arrays. Each array is an object. And inside the object, the data field can be expanded to allocate any number of data objects. So this is a very flexible structure. And then we have to change the values of constants. And we have is to a vector, re-vector execution programs. And I think we also have does to do customize the words. But I think we still have some bugs in the does, and hopefully we'll get it done sometimes this month. Okay, and the last but not least is the outer interpreter. The outer interpreter was the bulk of a for system. In eforth, the bulk of the words are defined because we need them to build the outer interpreter. And here, in all these three object-oriented eforth system, the outer interpreter is implemented as a single routine, which is called from the